Beautiful. All right. So, welcome to lecture 8, where I think, it's a touchscreen, but it doesn't work the way I want it. So, what we're going to do today is talk about the rule following paradox. I have to start by saying this is, honest to God, one of my favorite topics. It is so weird and so annoying, and it feels like there should be an answer, but we'll talk about why maybe there isn't. So in particular, the plan for today is to start off by talking about the paradox itself. And after we've sort of set it up and what exactly it's trying to present, we'll talk through a bunch of potential solutions. And I say potential because there's going to be rebuttals to every one of these potential solutions. And it's worth noting that if there isn't a solution, the result is absolutely catastrophic. It is going to be that argument we had at the very beginning at lecture 0, that there is no meaningful communication, it's going to come back. That maybe the result of the paradox is there isn't any communication. We're all just whistling at each other, which is cool and very sad. I would hope that there's something more than that. Now, the place to start with it before we dive into the paradox is to, as always, like all good jokes, explain the joke in the picture. So the paradox comes from, or originates in, I guess is a better way to put it, the later Wittgenstein. So Wittgenstein, hopefully people have heard of him before. I don't know how much you actually got to read from him or anything. There's good and bad in that. Yeah.
We never read Wittgenstein directly, but we have a whole course of feminists that go on the tradition of Wittgenstein.
In the later Wittgenstein, I think.
Probably, yeah.
So this is actually going to be coming from the later stuff.
Okay.
So this is the paradox we're going to talk about is a byproduct of his discussion in his second book, published posthumously, called Philosophical Investigations. So part of that very, very wide-ranging book is an argument against the idea of private languages. So this is a language that never, ever is communicated to other people. It is only ever spoken to yourself. And Wittgenstein argues quite extensively that those are impossible. It's not actually a language. Now, the rationale for that argument, we're not really going to go over, but the kinds of reasons he uses there are going to be used to formulate the paradox we're going through here. So, the case we're going to talk about comes from him, but it isn't his. Instead, it's directly from Saul Kripke, whose work we read before, I think in lecture 2 or 3, lecture 2. And it's something that Kripke did kind of later in the early 80s, where he read this argument about private languages and realized that it can be read as raising a problem for following rules more generally. And so what you get is the paradox is the Kripkenstein paradox. Kripke puts it as, it's not his paradox, it's not Wittgenstein's paradox, it's not Kripke's paradox, it's Wittgenstein understood by Kripke's paradox. So we call that, again, Kripkenstein, right? Beautiful. So again, as all good jokes, the best jokes are the ones you have to take 5 minutes explaining. So what the hell is it? I've said the word paradox a lot. The long and the short of it is going to be that there is no way to satisfy a rule. Every time you think you're following a rule, there's no guarantee that you are in fact following the rule. That is the gist of the paradox. In order to get there, we're going to talk about a weird mathematical case. So, Wittgenstein formulates this in section 201 of Philosophical Investigations. This was our paradox. No course of action could be determined by a rule because every course of action can be made out to accord with the rule. One way to think about the opening claim there is that Rules are functions. Functions are cheap. So we can reinterpret any action as satisfying the function if we just kind of muck with it a little bit. And Kripke's aim in what we read is to spell out a version of this paradox. As he puts it, right, again, I said this a second ago, present paper should be thought of as expounding neither Wittgenstein's argument nor Kripke's, rather Wittgenstein's argument as it struck Kripke as it presented a problem for him. Just sort of situating it. It's worth noting Kripke uses a mathematical example because it's one where it seems like the rule is clear, but there's no sense in which it is restricted to maths. This is going to be an argument that could be applied to anything that seems to be rule governed. And here's the big trick, and this is why it's relevant for us, including language use or meaning expression. So we might think that one of the upshots of things like conventions, of things like the social and the formal conceptions of language, is that there's some kind of rule-like association between strings of sounds or symbols and meanings. If the paradox goes through, there is no such thing. Or at least there's nothing that guarantees there is such a thing. To formulate the paradox, we're going to talk about two mathematical functions. There's plus and there's quas. Both look the same. For ease, we're going to express the two using different symbols. Plus is the one that you learned. Quas, right, it's our little plus sign with a circle around it. Addition is going to be the standardly defined function where you take your first sum, you add your second sum, and you get a value. So, 5 plus 7, cool. You start at 5, you count 7 more spots along, and you get the result, 12. Quaddition, right, the function using quas, is very similar, but it diverges at a certain point. So, x quas y is just like x plus y as long as the result is less than 57.
That's not what it said.
Oh, sorry. If we can put it either way, right? Either one can be less than 57. The total is meant to be less than 57. Doesn't matter. This is the beauty. We can also have multiple versions of the quas function too. Right? All that matters is it behaves exactly like addition up to a certain point. The thing is, right, quaddition differs in that, again, we'll go with the version I gave a second ago, if that when we add them together, the result is greater than 57, it sums to 5. So, right, if you had, just use this different version where we add them and it's more than 57, right? If x is 55 and y is 5, then when we quad them together, we get 5. Now note, the particular function we pick here doesn't matter. It is an example. The idea is that up until a certain point, it behaves exactly like addition and then splits. That's the important thing for the paradox. Okay. So far, so good? So here's the skeptic's question. In the past, every time you've used this symbol, did your use of that symbol mean plus or quas? And the thought is, any evidence you might cite for using plus in the past is going to be consistent with your using quas. Now let's just stipulate that you've never done anything where the total sums up to more than 57. So again, the rough thought is, as long as you haven't hit the divergence point yet, every past instance will fit with quas or plus, and there's nothing that's going to tell you that your past use was one or the other. Nothing wild and crazy there. Importantly, External stuff isn't going to help, because no matter how many computations you've done, by stipulation, you won't have done one featuring any number larger than 57 or coming to a sum that's larger than 57, whichever one you want to use. What we're after here is something that comes up frequently, and I hate these kinds of questions. So if any of you guys have ever done stuff on like the SAT, or you get something like this in the LCAT test, where you're given a sequence, and then they ask you, so what's the next thing in the sequence? They're trying to get you to make the inference to the pattern, right? Figure out what the rule is. Those are bullshit, because every single pattern is compatible with every single fucking answer, right? So Kripke talks about this, right? You have an intelligence tester who gives you a sequence, and the sequence is 2, 4, 6, 8, and asks you what's the next number in the sequence, right? Well, an intelligence tester may suppose there's only one possible continuation. As Kripke says, mathematical and philosophical sophisticates know that there's an indefinite number of rules compatible with such finite initial segment. So what's the problem? Right? Any finite amount of past instances is going to be perfectly compatible with an infinite number of possible rules that you are seemingly following. Note that it's always about your past uses. So it's not really about what you're doing now or what you will do in the future. It's what guarantees that your past use of that symbol was this rule rather than that one, this function rather than that one. Because it's always about rule following, not what you're doing now, not what you will do in the future. So external stuff doesn't help. Internal stuff doesn't seem to help either. So to quote Kripke, no matter how many computations you will have done previously, even if God were to look into your mind, he could still not determine what you meant by plus. So here's the thought. Your rule, or what rule you're following, isn't settled by your intention, right? Because your intention, right, is either going to be a finite string. I intend to do this, or you're intending to follow some rule, but you could be following it wrong. You intend to follow the plus rule, but you're screwing up. You're actually following the quest rule.
Yeah, so, I mean, why could, if God were to look into my mind and he could see what my conception of the rule is, namely that indeed we take the first thing and we take the second thing, we squish them together, no matter what the particular values may be.
But note your conception and the rule can differ. That's the gap here, right? What you think the rule is and what rule you are following could be different things. That's why the intentional stuff or the internal stuff isn't going to settle what rule you are in fact following.
But in some sense, it does sort of show what I'm trying to follow, what I meant when I wrote down the...
What you wanted to follow rather than what you were.
Yes.
Yeah.
What I meant in some sense.
Well, so there's a trick here, right? There's the what you meant as in like what you wanted, and then there's what you meant as in what you were actually conforming to. That's the gap. That's the gap. So it would then give you that sense in the first kind of like what you wanted to do, but it doesn't give you what you meant in the actual like what was really happening kind of sense. So that's a gap there, right? And this is tricky, especially given the Gricean stuff we talked about, right? Where there's a kind of sense of intention, where intention is supposed to fix meaning in some way. So one interesting thing to do is to think about, right, what features of the Gricean picture could fail here. So remember the kind of reflexive intention, right? You intend for this, you want the other person to recognize your intention, and you want their recognizing that intention to kind of convey. Now what we get is that Using the plus sign, you might be trying to convey addition, but you might fail. That's the split. So the thought, to go back, external stuff isn't going to help because no matter what, you could have only ever done some finite amount of computations. Internal stuff isn't going to help because there's a gap between what you want and what you might be doing. Now we could maybe get around this if we could do super tasks. Super tasks being where you make an infinite number of actions within a finite period of time. But pretty unlikely that we can do that. There's reasons to think that's physically impossible.
But mathematically, that often happens, right?
So, yes,
you can do an infinite addition, for example.
You can do an infinite addition. We can't. Right? In principle, somebody could, but we can't. That's the problem.
Oh, but you can mathematically prove that there is a result, for example. So
yes, you could. But basically, what you do in those cases is you prove a kind of condition. If you performed this infinite activity, you would get some conclusion. We can't get the conclusion by itself. We only get the condition.
But even an infinite series would still have presumably infinite explanations of that series, right? So if you would, for example, do an infinite addition, going 1, 2, 3, and so forth, it could also be, I don't know, a sine function crossing an x-axis and some formula instead of just being a linear.
Well, so the trick is here. If you could do an infinite number of steps, then you could show at every instance that you've avoided the variation rules. Because, right, every choice point, at least as we're kind of defining the variation functions, is like, oh, it hits a certain point and then deviates. So if you have an infinite number of steps, there could be
for every conceivable situation.
Yeah, that's what it would have to be, right? Which
and what about an algorithm implemented on a machine, on a computer, for example, or the Leibniz thing they want to sell in France?
We're going to come to that.
Okay.
Because this is one of the possible solutions.
Okay.
But it's going to, just to spoil, it's not going to help either. Or at least it isn't clear how it helps.
Yeah.
So again, the skeptical argument, given a finite number of previous activities, there's no guarantee that your previous uses of that symbol were tracking plus rather than quas. Your external activities don't settle it because by stipulation, they don't reach the point of divergence. Your internal stuff doesn't matter because there's a gap between intent and act. So, yeah.
If you turn them around, if you focus on cus instead of plus, you can still do it, right? You can still differentiate.
The same point would go the other way. So note, I introduced you to quas because I assume you're familiar with plus.
Oh.
But I could have done it the other way.
True.
Right? So that's the neat thing here. I introduced you to quas because I'm pretty sure you know plus.
Yeah.
But it could be that you've actually been using quaddition instead the whole time. Maybe not the one that we've done, because I'm pretty sure everybody's done addition sums bigger than this. But pick some big number.
Yeah.
We won't have added more than that.
Right.
So, the skeptical conclusion. There is no fact of the matter. Nothing justifies my past uses of that symbol, meaning plus rather than quas. So, as Kripke puts it, was there some past fact about me, what I meant by plus, that mandates what I should do now? When asked for the answer to 68 plus 57, I unhesitantly and automatically produce 125. But it would seem that if previously I never performed this computation explicitly, I might just as well have answered 5. Nothing justifies a brute inclination to answer one way rather than the other.
And what was again the internal argument against it? That you could have made a mistake? Or?
So there's a kind of gap between what you might want to behave according to and what you do. And the way you could kind of extend this is if all you're doing is kind of projecting the kinds of results you want to get, there's going to be a finite number of those results. Because otherwise you're going to be sitting there doing projecting for a hell of a time. And as soon as we have that finite number of results, there's this possibility of not achieving the aim that you want. There could be a gap between the wanting and the doing.
You could intend to follow the rule to do it wrong. But is that, yeah, of course you can make mistakes, but I'm not sure how that's a counter argument.
So again, the thought is that you could have the inclination to behave according to one rule, but your actual behavior might accord with the other rule. This was again what we were talking about before. Your desire is to do addition, but perhaps you end up doing coaddition. Or your desire might be to do these kinds of functions every time, but you make a mistake and you behave according to a different function.
I think this is a bit weak, right? You can always, then you can prove nothing. So yeah, you can say, hey, but actually you mean... okay.
So this is the thing. It feels like there should be an easy solution here, right? And we're going to talk about some in a minute, but it's useful to kind of get the feel for it. Yeah.
Is there any difference when plus and quas, so take 2 quas or 2 plus 3, that's exactly 5?
No.
Or...
So again, kind of by stipulation, up until a certain point, they behave exactly the same.
Yeah.
And then you hit a point of divergence.
Yeah, okay, so no.
Yeah, that's the thing. And it's not divergent by time. So have people done like Goodman's new riddle of induction? Have you guys heard of this before? Okay. Pen, we'll come back. Goodman's new riddle of induction. Everybody's familiar with the riddle of induction, right? Hume, problem, right? There's no kind of justification for induction, blah, blah, blah. Okay. Goodman's new riddle is that when we think we have a certain property or predicate, there could be an infinite number of different properties of predicates at play. Take the chair. The chair is green. The chair is also grew. Grew is the property of being green up until time t and blue after. As long as t is in the future, we don't know if it's green or grew. This is a problem because now we can undercut our inductions not by questioning the process, but by questioning the content. Even if induction as a process goes through, we can't make any inductions about past properties of this thing because we no longer know which property it has. The rule following stuff is broadly the same, but now instead of thinking about which predicates we're applying, we're thinking about which functions we're using. Much in the same way that with the GRU, you have coextensiveness up until a certain point, and then extensions are different. In this case, we have behavior is the same, the extension of activity is the same up to a certain point, and then divergence. Now, why does this matter? Well, this is what it's driving at here. The skeptical conclusion. If your past instances are indeterminate, if you like, between plus and quas, you have no justification for your present inclination to use the plus function rather than the quas function. You should be equally justified in answering 5 when asked this as 125.
That's totally separated from like environment you're in, right?
Same thing's going to be true for everybody.
Okay. Yeah.
As long as there's some number that none of us have added to, which is true. Cool. So this could be you, this could be all of us. Importantly, it could be that you're using quus, I'm using plus, and he's using fuss. Right?
Yeah.
Or each one of us is implementing a different function, and we just haven't hit the point of divergence yet. And importantly, the past evidence would support every one of us when we give the answer. When we all give different answers. There's no justification for picking one rather than another. It's a weird paradox. And why is it a paradox? Because this is obviously bullshit. I think this is kind of close to what you were before. It's weak. It feels weak. It feels so obviously wrong. But there doesn't seem to be, at least so far, a good kind of justification for thinking we were always doing plus, and hence this is why when I say 125, I'm doing it right. So here's the big problem. It generalizes. There's not going to be facts about meaning at all. Again, I'll just read the Kripke. If the skeptic is right, the concepts of meaning and of intending one function rather than another will make no sense. For the skeptic holds that no fact about my past history, nothing that was ever in my mind or in my external behavior, establishes that I meant plus rather than quus. Again, in this substantive sense of meant rather than just intended. If this is correct, there can of course be no fact about which particular function I meant. Note that we're talking here about the mathematical function, but the same is going to be true when we think about things like denotation, when we think about things like predication. Every bit of language is going to be subject to this.
So would Kripke say that when I do addition that I know what function is in my head? I don't know it. Okay.
Not in any interesting way, right? You can know which one you're trying to do, but again, there can be a gap between what you're trying and what you're doing.
But if I try it and I do it right, in some sense, I
But it's going to be coextensive with an infinite number of other rules, other functions. So this is why you couldn't even know that you're doing it right.
It's also, I mean, let's say that I think I know what I'm doing is simple addition. And you could ask me any question you could think. You could ask me an infinite series of questions, and all of my answers would come down to taking these two things together and then counting them as a whole. In what sense then don't I know what I mean?
So this is why, again, when we're thinking about the kind of problem, it's got to be such that we're only ever doing a finite number of things. If we did an infinite number of things, then maybe we could resolve.
But if I could respond, if I could respond correctly to any of the infinite questions that you could ask me. So in what sense then don't I know that I'm using addition?
Good. So I think what you're thinking about is something like one of the accounts we're going to look at is a response. You have something like a disposition. So it's not that you do respond to every question, but that if prompted, you would give the appropriate response. We're going to talk about that later. Yeah, good. This is a very natural kind of move, right? So it's evoking what we might think of as like a modal property. I haven't been asked this question, but were I to be, I would give this answer. So we'll get to it. But the quick and dirty answer is that as long as there's a finite number of things that your disposition is attracted to, the same problem's going to come back up. It's going to overlap with the disposition, if you like, is indeterminate between a bunch of different ones. But the deeper worry is what justifies in saying you're doing it right. That's the real deep worry.
And then in a language kind of sense, so that what justifies me saying that we have the same idea? Yes, okay, I get it. So it's about sort of the idea outside of just myself.
Yeah. Okay. So the upshot, again, of this weird case, which is really closely related to these paradoxes of induction, these problems of induction, but it's distinct, is that, well, if that's what we've got to go on, then it doesn't really look like there's any way to track meaning.
But it's still, I have the feeling that it is based on the fact that you can make mistakes, right? So I'm just wondering about mathematical theorems, which are probably considered the most certain things there are. But for example, there are an infinite number of prime numbers, right? You can prove that. Euler did. It's an easy proof. But he could be wrong. He could have made a mistake.
Mm-hmm.
So, and gazillion mathematicians after him repeated the proof. They all could have made a mistake. So this theorem is not certain. If you allow this kind of reasoning, then then obviously everything becomes uncertain, right? So what?
Good.
You should start somewhere.
So this is actually kind of a neat thing, in that I mentioned again, this comes from the Wittgensteinian stuff. And one of his big concerns, another one of his unpublished things that came out posthumously, was exactly uncertainty. And one of his deep worries was that there is nothing that guarantees this notion of certainty for broadly these kinds of reasons. It's at least prima facie conceivable that you could have what he calls a cautious man. You give him the proof, and the response to the proof is, I'm not so sure about this. Either because they have worries about particular steps, or they think that there's some kind of implicit assumption that's been made that hasn't been shown to not be there, or they accept the rationale of the proof, and like the tortoise with Achilles, they don't make the final step to the conclusion.
Yeah.
In those cases, it's not just a kind of like, oh, you could be wrong. There's principal reasons for thinking that something might be wrong. And until we close those off, which maybe we can't do, there is no certainty in that sense of
So
certainty.
you have to stop somewhere. Yeah.
So is this, in what sense does it really differ from sort of Cartesian doubt? Just saying, well, everybody might have always been wrong about this thing that seems very obvious.
Good. So in this case, it still allows that a bunch of people are really doing behaviors and really doing things and we're really engaging, right? It's not doubting any of that. And it's not really about the kind of like we could be wrong sort of stuff, other than in that little bit about internalism. It's just that, look, every kind of finite sequence of behaviors overlaps with an infinite number of rules, so there's no justification for saying you're doing one rule rather than another.
Yes.
So in that way, it's not, you can see Cartesian doubt is basically saying it's not even clear that anything's happening at whatsoever. This is, a bunch of things are happening, but it's not clear what rule is applying in these cases. Behavior is occurring, but what's the rule for the behavior? Okay. Cool? Okay. Let's see where we're at. I don't have the time. Wonderful. So it's worth stressing, the paradox is not skepticism about mathematics. Right? This isn't a problem about plus or addition. It's a problem about functions, largely. Plus and plus are perfectly legitimate functions. Functions are cheap. It's just a mapping. You have an input, you have an output. Fine. These are good functions. It's a problem about which function are you behaving according to. And hence, it's going to be skepticism about meaning more generally. How do we know? We can put this epistemically, but it's probably better to think about it as a justification question, right? How do we know which of these two perfectly legitimate functions was attached to our uses of that symbol? And I want to stress, too, to go back, when I introduced you to these two symbols, this was just to kind of get the concept of quos going. What we really have is that there are these two functions and that symbol, and we're not certain which of these two functions is being expressed by that symbol. This was me assuming you already linked the two. But in light of this, in light of the argument, that was probably just a presentational flight of fancy.
Could name them +1 and +2.
So now we just don't know which one's which. So there's a really silly case that happens in the 2010 World Cup, where the 2010 World Cup added a version of the offside rule. They changed it to where the goalie was exempt from the rule. So you guys know how the offside rule works? Okay, probably better than I do. But the referees didn't know about the modification to the rule, and it had not come up until, I think it was a round of 16 game. And Mexico scores, but shouldn't have, because they violated the modified rule, but nobody knew. So it's a fun case where everyone was thinking they were obeying the offside rule, but they weren't.
So wait a minute, they changed the rules, but they didn't tell the referees?
They told the referees, but they kept playing with the sort of old rule, and because the case...
There was no difference.
Yeah, because it hadn't come up until this particular play, right? And then this particular bit of play happens, and they realize, like, oh shit, we've been using the wrong rule the whole time. That's the kind of fun. It's a jokey example, but it's a neat kind of case, right? Again, it's just to also drive home that this isn't really a problem about mathematics. Mathematics is a really easy instance to talk about because we can so explicitly formulate functions. We can explicitly formulate rules, like we can with games. Another very jokey, similar one is if everybody plays Monopoly 1,000 different ways, right? Everybody has their own kind of house rules. So
dialects.
Everybody can think you're playing the same game, and then somebody lands on free parking, and they go to grab the money in the middle, and you're like, no, dude, that's not...
Come on.
Yeah, exactly. Oh, I thought we were playing the same game. In a sense, you kind of are, but in another sense, you're not, because you just haven't had that situation. If you get that, you've already got the problem. Right? The plus and
this
plus.
is also consistent with following no rules at all, right? You can just pick a random number, and all your previous calculations of plus
just happen to line up.
be.
So there's a sense in which that's still following a rule, right? Because that is a function. That is going to be a mathematical function. It's just a mathematical function that says whatever input you get, go to that output. In fact, there's strictly going to be an infinite number of random functions where input maps to whatever output you want. And then there's another one that's very close. Input maps to different output. All of these are good functions. All of them will be random. Right? But functions are cheap. Like, it's just a table.
Yeah.
So cool. But yes, it's really hard. Once you understand, if you think rules can be characterized by that kind of thin notion of function, it's very hard to make sense of something not following any rule at all. Because just by definition, we could take its behavior, produce a function post hoc.
Yeah, but it's only in hindsight, right?
Yeah.
You can't do it up front.
But that's okay, right? Again, the behavior would still be rule following.
Yeah.
We're coming to know what the rule is in this sort of backwards way. Okay. So the skeptical challenge has two parts. Is there any fact that I meant plus, not quas? In what did my meaning plus rather than quas consist? Oh, sorry, that should be quas there. Apologies. Yeah, because otherwise, that's a really hard question. And the second kind of worry or challenge is, whatever we say here, do I now have any reason to be confident I should answer 125 rather than 5, given what I want to be consistent with my past intentions or usage?
But for one, I think you can give an answer to that. You can write down the algorithm step by step without doing the addition, but then the intention is in the algorithm.
Cool. We're going to get to this,
Okay.
I promise. there's going to be an internal version of an algorithm or an external version of the algorithm. And both of them are going to face problems. But we will come to it. I like it. I like it. So finally, again, like the problem is not how do I know that 6 plus 7 is 125, which could be answered by giving an arithmetical computation, but rather how do I know that 6 plus 7, as I meant plus in the past, should denote 125. If the word plus, as I used it in the past, denoted the quus function, not the plus function, my past intention was such that I should have replied 5. So in that sense, it's a question, if you like, about the relationship between this string of symbols and the underpinning denotation. Okay. So that's put us at 33. Before we take a break, we'll pause. Yeah.
Whatever you do,
Don't.
For more information, please reread this post.
Yeah, it's good. It's good. Again, we'll pause. We'll ask, are we feeling reasonably comfortable with the kind of characterization of the paradox? Again, as Kripke puts it, I love this line. Sometimes when I have contemplated the situation, I had something like an eerie feeling. Yeah, I get that. I get
it's
that.
also annoying.
It is, as with all of these puzzles, right? So what we'll do, we'll take a break. It's 34. Should we take a break to 45? Is that okay? 11 minutes? And we'll come back and we'll talk about possible solutions. Cool. All right. Take a break. Come back.